Hi everyone, so this is question 1, and remember with these questions we talked about in the revision session that we should follow the steps of Mr. T. Okay, and this stands for moles, then ratio, then triangle. And the two triangles that the triangle bit refers to are the two triangles that relate moles to mass and moles to concentration and volume. So the first one is that mass equals moles times a relative molecular mass, or MR, and the second one is that moles equals concentration times volume. So here it asks us to calculate the maximum mass of butanol that can be produced from when 1.4 kilograms of butene reacts with excess steam. So this phrase excess steam means that we don't really have to worry about how much steam there is there. If there's excess steam, that means there's more than enough steam to react with the butene that we've got. So our first step, moles, we need to work out the number of moles of anything that we can in this question. And we've been given a mass of butene, and so that's what we can work out number of moles of first. So the moles of butene, which is the C4H8, will equal the mass over the relative molecular mass of butene. Now we've been given that, it is here. So that will equal not 1.4, because this 56 here, that is in grams per mole. So 1 mole of butene will weigh 56 grams. So if we're going to do this properly and work out number of moles first, we've got to convert this into grams. So this equals 1400 grams. To convert kilograms into grams, we multiply by 1000. So that's going to be 1400 divided by 56, and that gives us 25. Now our next step, ratio, that refers to the ratio in this equation. And here there isn't really a ratio to use. Everything has no number in front of it, so it's 1 to 1 to 1. What that means is that if I've got 1 mole of this, then it will make 1 mole of this. Okay, so if I've got 1 mole of the butene, I'll make 1 mole of the butanol. So that means that the moles of the butanol, C4H9OH, that equals the moles of the C4H8, which equals 25. So my last step, the triangle, that means I have to choose the appropriate triangle. We've got to go back to the question and see what I'm working out. So I'm working out the maximum mass of butanol. So the triangle that has mass in is this one. So mass equals moles times MR. So the mass of the butanol, C4H9OH, is going to equal moles times the MR, which equals 25. We haven't worked out the MR yet, the relative mass of the butene, so we need to work that out. So the numbers we need are here, the relative atomic masses. So to work out the relative mass of the butene, we need those numbers, and the butanol, I apologise. So that's what we need, and that's that formula here. So let's just work that out over here. So if it's C4H9OH, that means that there are 4 lots of carbon, there are 10 hydrogens, there's 9 here, but there's also 1 here, and there's 1 oxygen. So if we work out what that all adds up to, the carbons each weigh 12, the hydrogens each weigh 1, and the oxygen weighs 16. So that gives me 48, 10, and 16. If I add all that together, I get 74. So to finish off this calculation, this is going to be 25 times 74, which gives me 1,850 grams. Now notice that they want this in kilograms, so I've got to then divide by 1,000 to give the answer. So it's 1.85 kilograms. The next question, question 2. So it says, In industry, sodium carbonate is made from sodium chloride solution and calcium carbonate in the Solvay process. The overall equation of the Solvay process is this. Calculate the maximum mass of sodium carbonate could be formed by reacting 40 kilograms of calcium carbonate in excess of sodium chloride solution. And they've actually given us both relative masses that we need here, so this makes it slightly easier. So we're going to be following, again, Mr. T, moles ratio triangle. So what can we work out the moles of? Well, we've been given the fact we've got 40 kilograms of the calcium carbonate. So that's what we can work out the moles of first. So moles of the calcium carbonate, which is CaCO3, will equal mass over the relative molecular mass, which equals 40,000, because again this is in kilograms, so this equals 40,000 grams. 40,000 divided by 100, which is the MR given there. So that gives me 400 moles. Then our next step is to use the ratio. So the ratio we've got to look at is the ratio between the calcium carbonate and the sodium carbonate, because we're trying to work out the maximum mass of sodium carbonate that could be formed by reacting to calcium carbonate. So here's the calcium carbonate and here's the sodium carbonate. So you'll see that there's no number in front of either of those, so the ratio of that is 1 to 1. 1 mole of calcium carbonate will give 1 mole of sodium carbonate. The moles of sodium carbonate that can be made will equal the moles of calcium carbonate, which will be 400 moles. And then finally, we need to use the appropriate triangle. Well, what are we trying to work out? Let's go back to our question. We're calculating the maximum mass of the sodium carbonate. So we need to use the triangle that has mass in it, which is mass equals moles times MR. So the mass of the sodium carbonate equals 400 times by the MR, which is here, which is 106, and that gives me 42,400 grams, and in kilograms that equals 42.4 kilograms. You just divide by 1,000 to get from grams to kilograms. So this next question, we can use Mr. T in a sort of, even though it's not really an equation, you're just dissolving the calcium chloride in water. But let's just go through this process. So we've got moles first, and what can we work out a number of moles of? We've got a mass of calcium chloride, and we've been given some relative atomic masses, so we can work out the MR of calcium chloride, which you always can do if you know the formula. So the first thing we can work out is the moles of the calcium chloride, which will equal the 11.1, and that's in grams this time, divided by the relative mass. So to work out the relative mass first, so the MR of CaCl2 will equal 2 times 35.5, that's for the two chlorines rather, and then add that to the 40 for the calcium, so that gives me 111. So that's what I'm going to divide by here, and that gives me 0.1 moles. Then, if we think about the ratio, well, for when we dissolve this in water, we're going to have the same number of moles. So that's the number of moles that we've got of calcium chloride in the water. So we don't really need to do a ratio there, because we're just working out the number of moles of calcium chloride that's going to be in the water. So the final thing is using the appropriate triangle. And the triangle this time, because we're trying to work out something different, we're trying to work out the concentration, we've got to use the moles equals concentration times volume formula. And to work out concentration, do moles divided by volume. So the concentration of the CaCl2 will equal the moles, which is 0.1, divided by the volume. Now the volume here is 500 centimetres cubed, but you'll notice the concentration, they want it in moles per dm cubed. Now a decimetre is 10 centimetres, so a decimetre cubed will be 10 by 10 by 10, which gives me 1,000 centimetres cubed. So to convert this into decimetres cubed, I have to divide by 1,000, which gives me 0.5. So I'm going to divide that by 0.5, and that gives me 0.2 moles per dm cubed, which is my answer. If we look at the next question. Some food colourings are a mixture of soluble coloured substances. Mixtures of soluble substances can be separated by paper chromatography. A food colouring is a molecular formula of that. Calculate a number of moles of this food colouring in a 0.5 gram sample. So this doesn't require a Mr. T, we're just working out number of moles. So we just need to use the appropriate formula to do that. So the formula we're going to use is mass equals moles times MR. The reason we're using that one is because we have been given a mass to use. The first thing we've got to do work out is the MR though, and that's what we get one of these marks for. So the MR, we've got to look at the fact we've got 16 carbons, we've got 12 hydrogens, we've got 2 nitrogens, and we've got 1 oxygen. I've got that from this formula here. So if we work those out, it's 16 times 12, 12 times 1, 2 times 14, and 1 times 16. You have been given all those here, but you could look them up in your periodic table as well if you wanted to. You'd get that in the exam. So 16 times 12 is 192. 1 times 12 is 12. 2 times 14 is 28. And 1 times 16 is 16. So add those up. We've got 18, 10, 13, 104, 248. So the MR will be moles rather, will be 0.5, which is the mass, divided by 248, which is our MR, and that gives us 0.002. So this next question, calculate the number of molecules in 2 moles of the food colouring of this. We've just got to recognise for this question that 1 mole is just a number, and that is this number here which I've given to you. So 2 moles will have 2 lots of this number of molecules. So to work out the number of molecules, you simply do 2 times 6.02 times 10 to the 23, and that gives us 12.04 times 10 to the 23, but your calculator probably gives it as 1.204 times 10 to the 24. Last one. 48 grams of sulfur dioxide is provided. Calculate the number of sulfur dioxide molecules, SO2, in this sample. So this requires a little bit more thinking about because we've got to work out moles first. So to work out the number of moles, we've got to use this triangle, which we've been given a mass, remember. So we've got mass equals moles times MR. So our moles equals mass divided by the relative mass, which equals 48, divided by, we've got to work out the MR of this, so we've got 1 times sulfur and 2 times oxygen, which is 1 times 32, and 2 times 16, which is 32 plus 32, which is 64, so it's 48 over 64, which is 0.75. And so to work out the number of molecules there, we've got to times that 0.75 by Avogadro's constant, which tells us how many molecules there are in 1 mole. So number of molecules equals 0.75 times 6.02 times 10 to the 23, and that gives me 4.515 times 10 to the 23.